So they say, what is the general term used to describe materials that are easily magnetized? Those materials are described as ferromagnetic. So just you can take in you can just note that down, that materials that are easily magnetized are ferromagnetic. And then now we're gonna go to the diagram. And they say this diagram shows the magnetic field pattern of two identical bar magnets with ends AB and CD. And this is the direction of the compass needle. So, do you know how to use a compass? Or do you know in which direction a compass is always pointing towards?
I'm not 100% sure.
So I don't know. Let's just go. Let me just Google a compass right now. So yeah, no, not school. What am I doing now? Images. So if you look at it, a compass has a needle, and this needle, the red one, if I remember well, the red one is magnetic, and this one is always pointing north. So okay, let me just you can even ask Google right now, is a compass always point, does a compass always point north? Yes. So just know that if they give you a compass, it's always pointing to the north pole of the magnet. So a compass is you can easily use a compass to find north. So when here they say the direction of the compass needle, and they say it's pointing in this direction, that means this direction is north. And since this direction is north, you can automatically, not automatically, but you know that the opposite direction of north is going to be south. And then they say the diagram, yeah, diagram does that. What important information about the polarity of B and C is obtained from the diagram? So now you remember that when two magnets are attracting, you're gonna have the magnetic field lines like this. But now, in this case, the magnets are repelling. So what can you say about these two? About the polarity of these two? Is it the same or is it different? Do they have the same poles, or are they like, or are they unlike? Something along those lines.
They are like.
Sorry?
They are like.
They are like. Yeah,
And like.
nah, they have to be like. Remember, okay, okay. Now this one might be going a bit too far, but okay. What can I use? What can I use? So what you should know is that when two poles are alike, there's going to be attraction between them. When they are unlike, or when they are different. But when they are the same, there's going to be a force of repulsion between them. So basically, I don't like, I'm trying to find a good analogy to say this, but the only analogy I can find is based on gender. So I mean, yeah. But either way, I don't wanna go into like gender and all that stuff. But you know what? Let's just say it like this, no? A man is attracted to a woman, but a man is not attracted to a man. So if you look at it like that, if this is male and this is male, there's gonna be repulsion. And obviously, that's why the two magnets aren't attracting. So the like poles, they repel, and the unlike poles, they attract. So I hope you get that cleared out. So they say a small piece of magnetic material is placed at X. So let's just say here we're placing a coin, because now is money attracted? Let's just say here we're placing a piece of steel or a coin that can be attracted. And they say exactly in the middle of the arrangement, will the material move? Write down only yes or no. This is repelling. This is repelling. Do you think this is gonna move? Because this is pushing the coin this side, and this is pushing the coin this side at the with the same force. Do you think this is gonna move? Just yes or no.
No.
Simple. And then now we're gonna go to the next one, where they say a small compass is placed at point Y. The north pole of the compass points away from D. So the field lines around the bar magnet CD point from C to D or from D to C. So you remember that the north pole, if it's pointing away from D, that means D is most likely the North Pole and C is most likely the South Pole. So do you think the field lines which travel from north to south will travel from C to D or from D to C?
From D to C.
Exactly. So the field lines will travel from D to C. And give a reason for your answer. I gave you the reason. So yeah. And they say give a reason why the Earth's magnetic field is important for our existence. So you remember when I told you about solar winds? You can just say the Earth's magnetic field protects us from solar winds, and that's it.
Okay.
Yeah. So every time they ask you about the Earth's magnetic field and why it's important, you can just mention solar winds. and that's fine. There's nothing more you need to mention. So I don't think actually, you know what? Do you have questions? Because I don't want us to move too fast. So do you have questions?
No.
Sorry?
No. Wait, you see here by the drawing by the magnets,
Sorry?
right? You know the drawing here by the magnets? I thought you said if it's a positive and then a positive, it will be a positive, and then a negative and a negative will give a positive. Do you know what I mean?
Sorry. Can you try to can you say that again?
I thought you said that if it's a negative and a negative, it will be positive, so it will connect each other and not repel.
Oh no, like that's I think you got it confused. That's for electrostatics.
Oh,
So
okay.
when we come to magnets, we're dealing with like the north and south pole. And when it comes to electrostatics, most of the time, it's gonna occur between a positive and a negative, why they're gonna bring them together and let that happen. But I'm also gonna go through this type of question with you, and also this type also. That's why I'm saying I don't want to give you too much information, because if I give you too much information at the same time, this is two different chapters. So do you have another question?
No.
Okay. So what do you think? Do you wanna continue? If you think like, okay, you've already processed all of this, do you wanna continue? Or can we meet again on Tuesday?
And we can meet on Tuesday.
Okay. So have a nice day. I hope you do enjoy your weekend. And
You
please
too.
send me those question papers so I can go
Okay.
through them. And yeah,
Okay. Bye. Thank
bye.
you.
What did this girl say?